I'm thinking maybe in the future we should switch to the Linux Foundation Zoom meeting. So in that way, I think the Linux Foundation teams can manage the recording better.
Whatever works.
Good morning, Eddie.
Hi, Eddie.
Hi. So
There are
many familiar faces.
Two Eddie here. One from NVIDIA and one from Alibaba.
Yeah.
Yep.
We're supposed to match, right?
Yeah.
Yes, it
to
was
meet.
cancelled. Yeah.
Yeah.
Due to some.
When do you guys come to the
settings.
US again?
It
no
will take a
immediate
bit more
plans.
time. Yeah.
Yeah.
Okay.
All familiar faces.
Yeah, Jeff. Yeah.
Hey, Eddie. Hey, Yuval, Eddie.
Yeah.
Another
of course.
Eddie.
Who is Eddie? Who is Shira? It's an Israeli name, but I'm not familiar with Shira
Hi,
India.
I'm from Israel. I work
What?
at Marvel.
For which company?
Marvel.
Oh, nice.
Sorry, I think I talk muted. Okay. Okay, I think we can get started. So, good day, guys. Welcome to join this SONiC AI Workgroup kickoff meeting. So, in the invitation, you may already see the agenda. So this meeting, we just, the main focus is we want to discuss some logistic stuff, like, how to run this meeting, the timelines. Then, we want to discuss what should be the goal, the long-term and the short-term goal in the 2024. Then, Wei from Microsoft will give us a quick introduction about the current, his investigation on the AI networking side. If you guys have other topics, and also we have times, we can also quickly go through that one. So that's the basically the agenda for today's meeting. I think that AI is a very hot topic. You can see, currently it's like the iPhone moment for the AI. That's why how to enable the support of the AI story with Ethernet will be also a hot topic. That's why we created this AI work group. So that's just a very brief contact for this work group and for this meeting. Any question? Okay, if no, we will go through the agenda, the topic one by one. I guess the first one is the meeting times, and also, how to run this meeting. So I realized that it may be a mistake to host this meeting with Teams. So I see a lot of the limitations. I'm thinking, maybe in the future, I will ask Lucy help to create a Zoom meeting to facilitate this work group. So I think that's maybe the first one. The second one is about the time. So are you guys okay with this timeline? So I'm thinking maybe we can run the bi-weekly meeting at this time slot. Is that okay with you guys? This one basically, previously this is the young work group meeting times. Now the young work group meeting is like bi-weekly. Then we have, every another week we have open slots. If no objection, so we can use this timeline then. Okay. Bi-weekly meeting.
Yanzo, are you presenting something? I cannot see anything.
Oh no, I didn't present. So
Oh.
I just discussed. Yeah, I have no slides. I didn't prepare any document. So maybe Wei will present later.
I see a lot of friends from the Israel side, so I just wondering what time it will be right now in Israel. Because I would say like if this one can move like 1 or 2 hours up, probably some guys from the China or the Japan can also join.
So it's
I can tell you, I'm in
8
Tokyo
p.m.
right
in
now.
Israel.
It's 3 a.m.
You're in Tokyo.
Yeah.
So in Israel, it's currently 8 p.m. I think it's the last slot, which is convenient for the Israeli folks.
Okay. Yeah, I guess for China maybe need be the difficult. All the slots, let's say for the PST from 8 to 10 is almost gone. So all has been booked by different community meetings. So that's why we just pick up this slots.
Okay, then we stay with this
Yeah.
one.
Okay, cool. I guess the next topic is like, what group Uber Go and what should we deliver, especially the short-term and the long-term goal. This one I would expect input from all you guys to basically it's brainstorming stuff to see, what should be focused. Feel free to chime in. Guohan, what is your thoughts? If no one speak, I will nominate. Hey, Guohan, you are muted if you are talking.
Yanzo, just so I understand, this new working group is initiative.
Can you hear me?
Initiative. Yeah, go on. We
Yeah,
can hear.
Yeah.
Yanzo, is it initiative from Microsoft to the community, or is it just community initiative?
Oh, this one is proposed by. Okay, that's a good question. I think the ask comes from the board. That is what I heard. So I just I just have to propose this work group and run this meeting. That's the background.
Okay.
Formally, we are under Linux Foundation rules and APRs and everything, right?
Right, that's true. So this one is not Microsoft. So this is a purely community stuff, SONiC community stuff. It's open source. All the discussion is open. All the message will be shared publicly. So pay attention, when you share your information. So do not expose any internal stuff. Okay. Sorry, go ahead, go on.
Oh, okay. Yeah. Can you hear me now?
Yeah.
Yeah.
Yeah. Maybe we should, first discuss like what is the scope for this AI group, right? So what areas we're going to, discuss, right? So on this AI, right? So maybe I think a few things like topologies, certainly, right? So, and maybe routing, there's some, load balancing routing, those kind of things. I think maybe also the scope for this group to discuss, right? So I don't know if there's others, right? So, but I believe, maybe, in terms of
So-
telemetry and other things, I think maybe also the scope, to discuss in this group. Yeah.
Yeah, so routing is one, congestion management is another one, telemetry is another one, and then and in-network computing is another one.
Sorry, what is another one? Compute?
In-network compute?
computing.
Huh?
In-network compute?
Oh, in-network.
Oh, you mean sharp like in network applications?
Yeah, so
Yep.
there's some proposals for Ethernet IP networks as well. There's some work in ATF. We can start looking into them.
I see.
So some of these topics are discussed in UEC. So how this working group and UEC, because UEC had a huge army there.
UEC is not sharing anything there under UEC IPR rules. I don't think we interact in any way. At least before they start sharing anything.
Actually, and also there's like, I think that, in regard to the UEC, right? I think there is also like one short on that front is basically, the SONiC is a real OS, right? So that, maybe, what, I don't know, like one of the, the group goal is to say, hey, can SONiC become a UEC spec compliant, open source nodes to support, right? To support UEC. Basically say, okay, SONiC is one of the network operating system that supports UEC, right? So that could be one of the work stream for this group.
So if you look at UEC, it has a number of working groups, link level, API level, 5 or 6 different working groups. So theoretically, we could establish liaisons to UEC, actually not to UEC as organization, to a particular working group within UEC that work on similar technologies as we do here.
Because I see that, for example, on the ANSI, those discussion is already quite heavy in the UEC, and also for the congestion control. So I just wondering, like, what is the role for this worker group if we may want? Because I probably thinking that like quite a lot of people will be joining in that working group also.
That one is okay. In my thought, as as Guohan mentioned, the SONiC is a very specific product. If UEC has some good, let's say, good best practice and were also adopted by the industry, SONiC can support and implement those kind of the technology. Another things like, I mean, if SONiC community can also propose.
Just to add this one, right? So I think think about other working group. Like for example, maybe in some working group we say, okay, we want to implement like SRV4, SRV6. So there's a spec out, right? So then basically in that SONiC working group, what we are mainly discussing is that, okay, how do we implement those that in the SONiC, right? So for example, in UEC they may have some routing or congestion, proposal spec, right? So therefore, maybe there's a need to be implemented on SONiC. And then, for this group, we can say, okay, hey, in order to implement this one, I want to implement this one SONiC, and then we can discuss, what is the proper way to, implement this on this one. Maybe that's a suitable topic for this group.
So I don't think you should be specifying particular organization, consortium, or SDO. Otherwise, you need to work with all of them, right? ITF has CC, HPCC. You look at IEEE, they're working on BTS, SPF stuff. So it's all very much related to AI networking. So you see it's in no way special from this perspective.
Hey, another angle I'm thinking is like UEC. Okay, let's say UEC topic will cover very generic things, but as a SONiC community, I think we can maybe focus on some specific things. Let's say UEC is not appropriate for UEC to adopt, but maybe it's okay for SONiC to initiate or use. That's maybe another angle. I mean, to me, it's like SONiC can collaborate with UEC, but it's not like, okay, we have UEC, then we should not with the.
Yeah, I would put it more generic. So this group is going to interact with other consortium and SDOs to adopt technologies that potentially develop that are applicable to AI networking. That would be probably better statement.
Okay.
And all SDOs have formal liaisons with different organizations, so it's a well-established process in both IEEE and IETF.
Just some ideas. No. Okay. So what should be our, sorry, go ahead.
No, I think what Jeff was saying was, no, use these topics and then SONiC is implementing it, right? So the architecture, and that's what I understood, at least from Guhan and Jeff. So
yeah, this is the first. You're right. So let's say you say, so SONiC just like SONiC act as the mention of the UEC proposals.
So yeah, I would replace UEC, which is specific consortium, with more generic SDOs or standard development organization and consortiums. Because again, there's more organizations working on topics related to AI networking.
Okay, Jeff, can you share that IETF working group where they're working on this one?
So the congestion control working group. This is where HPCC is. This is where SONiC is going to move to. SONiC is new proposal by Google that is published in IETF. It's in IPPM now. We are moving it to CCWG next IETF.
This is a CIS proposal from Google and Broadcom last OCP we saw. Is that you're talking about?
It's not just Broadcom. You'll see new drafts where NVIDIA, Cisco, and HP are present as well in the draft.
Okay.
So it's going to be collaboration.
Okay. Jeff, it would be helpful if you can share the link to that working group for us. That'd be great.
CCWG in IETF.
Okay.
Can I repeat?
Congestion control working group.
Just Google that one?
No, CCW in IETF.
CCW in IETF. CCW, right?
Yeah, this one. Yes.
Oh, okay. CCWG. I see. Okay, maybe we spend 5 minutes to discuss our short-term goals. So what should be our focus in the 2024? I think we have a long list. Do we have do you guys have any idea about the specific focus or deliverables in the 2024?
So probably it would be helpful to establish a set of features that are important for AI networking. So congestion control, proper load balancing are one of those, right? Some of this is in SONiC already, some of this is not, some of this is half-baked. So it would be helpful to establish framework as to what should we work upon, and some things are obvious. We know what they are.
Okay, I think congestion control is a good topic. Right? This one is pretty hot.
It's a very good topic.
Generic, yeah. What else?
Adaptive routing and switching, right?
It's
one of the
balancing,
OCP. Yeah, one of the OCP, Guhan and Broadcom presented that. I think that's one of the good features for the AI fabrics.
Okay.
Adaptive routing is a very unfortunate name. It's actually adaptive forwarding.
This one, I was wondering, like, whether in the UEC they have some specific specification on this one, or
So they publish nothing, even if they
published?
produce something. Just a moment. They publish nothing. There's nothing published. So it's only available to UC neighbors, which is not everybody on the call is. Number one. Number two, it doesn't really mean that when they publish something, it's actually good, implementable, or sane, right? It has its own dynamics, politics. We all know this. So it is like any other consortium organization that's going to publish some documents, and it's up to us in this group to decide whether it's something we would like to look into.
The next is the Rocky V2 related tunings, buffer tunings, and all those things. We don't have that today. We can have only the static mappings. So if at all we want to dynamically change headroom and other stuffs, right? In one of the Mellanox platform supports headroom related stuff, but it's not on other platforms. But moreover, we need a lot of tunings there as well. So it's very limited right now, whatever is available.
In general, I agree.
Yeah.
Okay. Yeah, I think maybe 3 is good enough. I mean, we have limited time in the 2024. I think maybe we can focus on these 3 topics in the following discussion. Make sense?
What do you,
I sure maybe
I think
I
we should.
see that.
I think.
No,
Yeah.
no, I think I think actually, maybe one of the maybe how do I say this, a deliverable, can be that, work people can work together and publish a white paper, right? So something like that to say, okay, so how the SONiC, is, for example, enabling, the community to build this AI networks, right? So maybe that is something, we can, either as a roadmap or, aspirational goal, we can put, something out, as a group, right? So, hey, we understand, AI networks and, what are the challenges there and what are the things, the SONiC as a community, would like to address, right? So, to this challenge and, what we're, plan to, work on, right? So, something like that, I think it would be also very helpful to, to hear the voices from the SONiC community.
That's a good suggestion. I think that one, if we want to write a white paper, then it can cover most of the topic, not just that it's 3. Either is fine, right? Or we can say, okay.
Right. I would really like us to try to take example from SONiC routing working group, which Eddie happened to chair. The end result as now is huge amount of code, huge amount of improvements into SONiC. So it's really tangible results that everybody benefits from. It's not just white paper. So eventually, I think we should define high-level APIs that will allow multi-vendor community to implement the features that are important for
that. I think that can be the API can be the next step. I mean, I think the AI part maybe we are still a little bit far away from the specific API definition.
But the goal should be running code, not marketing.
Yeah, and Jeff, right? This could be, I think, see, I see value in both. I think this could be a good starting point in defining what is our aspiration, like Guhan pointed out, and where we stand today, SONiC, and what is the aspiration where we would like to go and what features we need to go. And then for Yanzo, right, we don't have to immediately tell what is the 2024 focus because this is our first meeting, right? So there are some basics, something is needed, but some of the base things itself is not there, right? So we need to make sure that what are the, just get a brainstorming of what list of features are needed and what are the low hanging fruits or basic things which to start with, right?
I agree with you completely. My comment with regards to terminology. So white paper is a milestone. the technical specification is the goal.
Yep.
Right.
That's part. Yeah, I agree. Yeah. Eventually, we want to deliver something can be used in the code. Okay. With that, I think we only have almost a half hour left, so I want to give some time to Wei to give us a quick, introduction about the AI networking side. Then we can see, I hope we can get some new ideas from the discussion. Then we can continue the future discussion and the future work group meetings. Okay. So with that, yeah.
Let me share my screen. Can you see my screen?
Yeah. But you represent Microsoft Research here, right?
Yeah.
Okay.
Hey, so Wei, are you okay to share this link for these slides, or maybe?
I will share the slides later.
Okay.
Yeah. So I think in China we have all seen that to throw a brick to attract some good ideas. So the goal of this talk is to to attract some good idea and to trigger more discussion in our community on the AI networking. So in the past 2 decades, right, we have built many data centers, and the data center network is server-centric, as it is designed to interconnect servers. But in the era of the AI, right, the GPU, we know that GPU become the first-class citizen. And in this figure, we interconnect, for example, in this figure, we interconnect 2 like DGX-like servers, each with 8 GPU. For GPU on the same server, right, they can communicate through a special switch, like called NV switch, and which I will talk about later. And for GPU across different server, and they communicate through this this cloud-like network. So it is worth to know that every GPU typically has a dedicated NIC. So you can think a DGS as 8 server, each with a GPU and a NIC. So there are mainly 2 GPU communication technologies, and the GPU within a host will use NVLink and NV switch, which is typically much faster than the PCIe, and the GPU across different hosts will communicate using RDMA or GPU direct RDMA. So NVLink and NV switch, right? This kind of like GPU direct interconnect. I would say they're vendor specific, right? For example, for NVIDIA it's called NVLink NV switch, and for AMD it's called FGMI. I'm not sure if our community should also work on this, but I would say that at least for now, in my opinion, we should focus on like the RDMA part. So you may ask that, okay, SONiC has all the necessary features to enable the general purpose RDMA over converged Ethernet V2 or Rocky V2 deployment. Right? For example, we have the share buffer, PFC watchdog, and ECN. And we also have very comprehensive test case, which are implemented using PDF and ECN. So the question is that, what new feature do we need for the AI-oriented Rocky or Ethernet networks, and why? So I would say that we do need the support for the new for the advanced load balancing schemes because of the low entropy nature of the AI traffic. So in the AI, the machine learning workload, the machine learning framework, they typically use like collective operation, and one of the most common collective operation, is called O-reduce. So here's an example of O-reduce. So as the name suggests, the O-reduce, right, has 2 words, O and reduce. The O-reduce operation is performing reduction on the data across device and writing the results in the receive buffer of every device. So it's reduction on all the device. So for example, here we have 4 workers, and each worker has 4 data. So let's say for the first data is 17, 5, 3, and 12. Okay, so the sum of this 4 number would be 37. So the result of the first number should be 37. And for the second one is 11, 13, 6, 7. Okay, the sum is 24, 6, 7 is also 37. So the result of the second element should also be 37. For the third element, right, is 1, 23, that is 24, 10, 34, 34 plus 2, that is 36. So the reduction result of the third element should be 36. So I mean, in this way, right, we perform reduction on all the data, on all the 4 elements. And we have this 37, 37, 36, and 43. And because we need to write the results in the receive buffer of all the device, of every device. So as we can see that all the 4 workers, they have, they have same result, like 37, 37, 36, and 47. And so to implement such kind of O-reduce operation, the most straightforward idea is that, okay, I have centralized controller. Okay, this can be any one of the worker node, and this worker node gather the data from all the 4 workers. Okay, it's like, so we will have first have a one-to-one communication. So after we calculate results, this worker node will broadcast the final results to all the other worker node. Then we have a one-to-many. Okay, this many-to-one, one-to-many approach is, it's very straightforward, but this creates a lot of, congestion bottleneck, right? Because this worker will, the bandwidth of this worker will, will determine how fast we can perform the calculations. So this is so there are some other like collective operations such as a broadcast, reduce scatter, and all gather. Okay, so their mechanism are different, but I think all of them can be implemented using such one-to-one, one-to-many approach. So we know that such like one-to-one, one-to-many approach is suboptimal because we have a bottleneck, right? So there are a lot of algorithms which try to optimize such collective operation. So one of the most famous algorithm, most popular algorithm to optimize collective operation is called ring. So if the O-reduce is implemented using the ring, we typically call this like ring O-reduce. Ring O-reduce has been widely used in the AI community. So let's say we have 5 GPU, right, and we can form a ring. So for every GPU only talk to another GPU, and every GPU also receive data from another GPU. It's like a ring communication. So in this way, we can see that all the in this way we don't have the single bottleneck. And another way to accelerate the O-reduce operation is called a tree algorithm. So the tree algorithm, the idea of tree algorithm is very straightforward. So let's say we want to calculate the sum of the following 7 elements, right? And we can perform aggregation like layer by layer. For example, here, okay, I have 2 elements, right? My element is 2, your element is 5. Okay, both of us transmit data to our parent node. It's like the value of the element on the parent node is 4, so we have 2, 4, 5, that is 11, and then we transfer this result to the root node, right? Eventually, through such kind of like layer by layer aggregations, right, we can get the reduction of all the element in the root node, and then the root node will broadcast the data layer by layer. So this is called trio reduce. Yeah, so of course there are a lot of other algorithms, but I would say that there are some interesting observation from the ring and tree algorithm. That is, a GPU can only in both ring and tree, right? A GPU can only communicate with a limited number of the GPU. So for example, here, right, I think you can see this node only talk to this node, and for node in the middle layers, right, they only communicate with 3 nodes. The two children node and 1 parent node. And also for the ring communication, right, every GPU only talk to 2 neighbors. So that's why I say that a GPU can only communicate with a limited number of GPU, and this is very different from other data center workload. And also in this case, right, we always talk about in-cut congestion in the data centers, but actually in both ring and tree, right, the in-cut congestion is significantly alleviated because we don't have the high degree many-to-one communications. So what are the unique characteristics of AI traffic? So on the one hand, right, the AI traffic, especially for the training, I would say the traffic pattern is very simple because we repeat the same, because training is a repeatable process, right? We repeat the same stuff for long times. And so that means the traffic pattern is also static and also can be known in advance. But the bad thing here is that, okay, the slowest flow in a collective operation will determine the total completion time of this collective. So such kind of 2 characteristic means both opportunities and challenge. For the opportunity, I would say that because the traffic pattern is very static and can be known in advance, So it's easy to optimize the AI communication through some application and network co-design. And for the challenge, I would say that in a collective, right, we have a lot of flows, and because the slowest flow will determine the total completion time. So a single congested or bad link, by bad link I mean, for example, the link with high packet corruption rate. So in this case, a single highly congested or bad link can slow down the whole AI job, and this is undesirable. So in the SONiC, we have been using the BGP and the ECMP to utilize the bandwidth of the redundant paths in our data center networks, right? And we all know how the ECMP works. Essentially, using the ECMP, right, the flow will take randomized implicit paths. But the problem here is that, right, because of the randomness nature of the ECMP, right, we can have path collision. And once we have the path collision, will result in the large completion time for the collective operations. So when the ECMP works well and when it works bad. So ECMP is not even though ECMP is random, is a random mechanism, but in some cases its performance can be really good, right? For example, we know that ECMP really like the light tail, flow size, and high entropy. One example is that, okay, in a cluster with 1,000 hosts, every host create 10 connections with every other host and send 1 megabyte data on each connection. In this case, I think ECMP can perform really well. It's probably close to the optimal solutions. But unfortunately, this is not the case for the AI. In the AI, even those old flows in a collective, they typically have the same size. But as I have mentioned, that AI workload, they have low entropy. Because in the tree or ring, right, a GPU can only talk to a few other GPU. It's not like any-to-any O2O communications. So that means the ECMP may not be able to achieve desired performance for the AI workload. And there are a lot of solutions to improve the load balancing and in the data center network. So here I list a few switch-based solutions. I generally classify the solution for 2 categories based on my knowledge. So for example, one category is the congestion-aware flow-light-based load balancing. We have a mechanism like, for example, the DLB and GLB and Conga. And essentially, all these 3 mechanisms, they no longer ping a flow to a random path, right? They can change the decision, they can change the routing decisions of a flow based on the congestion state of the network. And actually, they perform the load balancing on the granularity of the flow net. So once we can see a big gap between the 2 packets in a flows, right, and the DLB, GLB, and Conga, they can make a new routing decisions. Another approach is that in the DDC architecture, right, we can perform the packet of cell spring and reordering completely using the switch without the involvement of the NIC. This is another approach, right? Even though all this proposal look very promising, I believe there's some problem. The first problem is that they all use like very vendor-specific proprietary protocols and mechanisms. So we have some high-level ideas of how it works, but we don't have a standard interface. And also we don't have the very efficient tools to monitoring their performance. So when everything goes well, that's fine. But if something goes bad, we don't know how to debug the solution. And also we don't have good testing tools and test case to help us to understand how this mechanisms works. So I personally think that the load balancing is a good starting point, but we should, I mean, in my personal opinion, we should start working on standardize such kind of like load balancing proposal for the AI network. So that's the end of my presentation, and thank you. I'm glad to take any questions.
Yeah, I'll provide a couple of comments. So the elephant in the room, really, if you look at CPU cloud, you've got one network. You go out of NIC, and this is the network. In AI cloud, so you've shown DGX server. They have internal network called NVLink that's 8 times faster. And it's actually a communication library that makes decision how to route traffic. So instead of one external, at least you didn't mention it, right? You've got you've got NVLink, you've got PCIe, so you've got two networks within the server to route packets between GPUs before you even go outside. So this is very important point because those are faster, but have different characteristics. So not all the traffic goes outside, and it's algorithm dependent, communication library dependent, MPI dependent, domain dependencies that need to be well understood. So it's not as simple as presented, right?
Yes.
Number two, with regards to load balancing, again, the elephant in the room is load balancing. When you do it not per flow, you reorder packets.
Yeah.
If packet reorder for RDMA operations that cannot deal with reordering, your application is you're going to kill the application pretty much.
Yeah.
So reordering is a very serious problem when you do something like DLB, which is oblivious to that. So again, I think we really need to include this point because they're fundamental to figure out working solution.
Yeah, so I understand your second point. That's DLB and GLB. They can, I would say, any flow based load balancing, they have some probability to introduce out of order, of course. And there are a lot of performance tuning work we need to do on this space. But I don't quite understand what we saw the community can do for the NVLink and the NV switch part.
So some part of the traffic is going to go over NVLink, right? So you will never see it in outside network. This needs to be well understood. So you need to understand what communication library is actually doing. My comment with regards to DLB is that neither DLB nor Conga work in AI networks for a very simple reason. They require interpacket gap when it's safe to move flowless.
Yeah.
There are no gaps in AI flows. There are large flows that go for a very long time. That's why you cannot really use Conga or DLB flowless switching in AI network. It doesn't work.
But in training process, right? Because you have computation, communication, right? And the AI typically use a long-lived connection, like for example RDMA QP, right? So I expect some idle time between two iterations.
It might take number of hours before you get idle time. Right? Again, for Conga to work, you need an interpacket gap large enough to switch the flow. It's configurable parameter on both Cisco and Broadcom Silicon, right? We do it differently in NVIDIA, but practically, it fundamentally doesn't work. And again, it's an important point to understand.
Okay.
The other thing is the traffic patterns for AI operations, for example, training, inferencing, and fine tuning and all those things, right? The traffic patterns may vary. From SONiC fabric standpoint, do we need to consider those aspects, right? Because accordingly, we need to do some kind of a fine tuning and all those things needed on the fabric side, right? So that's something we need to.
I think this is a very important point. We kind of implicitly talk about learning only. Inference has very different characteristics, different flow, different duration. So I completely agree with you. We need to explicitly mention it.
Training and inference totally different.
But the tuning part is actually very specific to the workload and also the infrastructure.
This way, I think isn't that? I think one of the topics we can also explore in terms of routing is that I think in the AI networks, a lot of the networks, when they talk about the design, they talk about the package spreading, right? So I think that's like a pretty common. So. But I think even in terms of they are doing packet spreading, I don't know whether the network need to support some kind of policy routing, so that for specific packet we need to do a specific spray. Like for example, maybe one of the challenge I can see is that if the NIC is doing or GPU is doing the packet spraying, then there might be challenges to find out where the packet is getting lost, and how would the NIC try to avoid such bad links, right? So if they were doing spraying, maybe they need to know, okay, I sprayed once on this link and got lost, and then later I need to try to avoid, right? So for this particular link, right? I think there were also some design points that we can work on to make sure even if the NIC is doing the spreading, then how does the network help them to understand, help them to avoid the losses on some of the links that
So it's a very good comment, because when you start spray from the NIC,
lossy.
Congestion control signaling changes completely. You don't have flows. So it's a very important topic to talk about if we are thinking about packet spray from the host. It changes half of the network or reaction of the network.
Exactly. Yeah, I think we shouldn't, that's one of the things we should not assume that, the NIC is doing the traditional flow management, right? So I think there is a common that industry is talking about packet spraying the AI networks, right? So very common.
Yes. So yeah, I would say that, so first of all, packet spraying can be implemented. So packet spraying has two parts, right? One is spraying, the other one is the reorder. And so I would say that if we use the switch to perform the packet spraying, essentially we can think is extreme case of the congestion where flow light load balancing. We just have flow light threshold to 0. But if the NIC perform the packet spraying, that means, for example, the NIC change the UDP source port of the Rocky V2 packet, then that's a different story.
Yeah, and it creates complexity in a way. You need to be able to create virtual logical channels. So you've got a range of UDP source ports that will eventually result in particular logical path throughout the network that you need to be able to monitor. It creates significant amount of state. It's really a complex solution. So we need to think through before you actually start spraying packets from the NIC.
At least for me, it seems that we should focus exactly on what Jeff is describing, because that's the unique position that we are in, that we can describe this kind of internal network, internal NVLink network, and how it influenced the network, and exactly all the issues that we discussed here are the issues that we are the right place to describe that.
The other one I want to see
I didn't quite understand this point. What is a unique position we have? I'm interested in this unique position, but what is this unique position that you think we have to address the problem?
I think we have here, as we said, we have here people contributing from all companies, and specifically those that have experience with deployments of both the internal network NVLink within the NVLink and what is done outside. And as Jeff described, that has a lot of implications on the load balancing and everything else within the actual network. So we have the knowledge here, and we can describe that, and we can describe the scope of the problem, and then later on have the solutions for that. Right.
One question I want to ask, the way probably like say, since you do you have like say any like a traffic pattern on those models, like say for all reduce those things from? Because before we try to say solve the congestion control problems, do we fully understand like say what the traffic pattern will look like? Do we can take any advantage on those kind of things? And
Yeah,
also like you see the traffic pattern will be changing once you're adding more node, like GPU node into the topology.
I would say that the traffic pattern of the ring and tree, they should be easy to understand. Essentially, it's like, for example, in the ring, right? Essentially, one GPU talk to another GPU. But the interesting here is that let's say the GPU 0 and the GPU 1, right? And they may locate in the same server or different server. So if they're in the same server, they will communicate through the NVLink or NVSwitch or XGMI. If they're in different servers, then they need to go through RDMA.
That's true. Yeah.
Yeah.
What and also, like I say, because if you go into say, for example, like from practice point of view, will you guys like I say do the co-location for those GPUs, because you kind of like this is more like a GPU topology, not the real like I say the physical topology. Do you get both view and co-locate those GPUs, try to reducing the traffic going to the network? In the sense you kind of limit your traffic as much as possible in the NVLink switch. Do you do those kind of practice?
So I think AI people will, because actually, if you talk to machine learning people, they all know that, okay, the GPU on the same host, they have the higher bandwidth.
That's true.
Because they know that NVLink NVSwitch is much faster than like Ethernet and InfiniBand.
Yes.
So they will have some like optimization in the application layer. For example, they can perform like all gather on the 8 GPU on the same host, and then they perform another collective using all the GPU across different hosts.
Gotcha.
So this is a situation where if you go into public cloud where you offer GPU as a service, suddenly you start giving GPU to one customer, another GPU to another. So eventually your scheduling becomes really, really suboptimized. So if you are building something for single tenant, I agree, you will schedule, you will keep locality. If you are thinking of public cloud, something like Microsoft or Google, eventually you will have stuff all over the place. That's the nature of multi-tenant cloud.
The cloud, AI cloud is a different story, because as far as I know, right, in the AI cloud, right, first of all, typically people will not lease for, let's say, 0.5 GPU. No one wants to share GPU with another tenant.
Not the GPU, but the server potentially. I mean, this has been packing.
So yeah, I know that, but server, because people know that the GPU communication within a DGX server, right, is much faster than going through the network. So I would say people tend to lease dedicated DGX server.
So you
again,
mean like
if you're building private cloud, I completely agree with you. In public cloud, eventually you'll end up in a situation you have to do in public cloud with VMs. You have whole bunch of different tenants, and optimization become really incomplete. So you should count on suboptimal job allocation eventually. From economical perspective, this is not in public cloud.
Yeah, so I think do we need to worry about the multi-tenancy as well? We need to capture
absolutely. Yeah.
But the multi-tenancy mainly for the inference, right? Not the training. For the training.
Why not? Again, if you are providing GPU as a service, you need max segmentation.
Oh, you mean for the external? Okay, that part. I mean that kind of the training, the scale will be far smaller. Let's see. That is yeah. Okay, I understand the point.
No, but look, half of people on this call are public clouds, right? Microsoft, Alibaba, you're selling GPU as a service. You must support multi-tenancy in order to provide the service. Otherwise, there's no service.
Yeah. Actually, I will be interested also like say because normally the training need more GPUs, right? So
much more, yeah, much more GPUs.
yeah. So in general, like I say, what because whoever do this such a big normally big customer, do you guys also do some kind of a pre-arrangement on these GPUs before the training start? Because normally the training will start for like once started. Normally it's a couple of weeks.
Yeah. So what do you mean by pre-arrangement? You mean the reserve certain
like,
GPU?
we carving the GPU like in physically co-located.
Oh, I see. I see.
Because those GPU normally you are asking, say for example 1,000 GPUs, and you are renting it for like say a couple of weeks. So I just wondering what you
So
guys.
Eddie, I can give you some. It's not an answer. The only public cloud that actually publish any documentation on this topic is AWS. So you can get topology from P5 clusters, and AWS very clear. We cannot guarantee locality.
Gotcha. Okay.
So this is
Yeah.
public.
Okay. Just the time checking. We have 3 minutes left. I want to thank you guys for the brainstorming and joining these meetings. Just one thing, you know, for the white paper, let's say if our goal is like deliver a white paper, how should we get that? I think we may need someone to create outlines, list the topic, those kind of the things. Not sure. Anyone want to be the volunteer to start this
I think it's a bit
paper?
early to start, but we need to use some collaboration to either GitHub or at least Google Docs, something like that, so we can.
Yeah, I agree.
Yeah.
But maybe my point is like we may need someone to start this preparation. Let's say whatever we want to use, Google or Microsoft GitHub. I just want to see if anyone want to volunteer to kick off this white paper stuff. That is.
Let's have a couple of meetings and then figure out who it is.
That makes sense. That works for me. Okay. Yeah. Okay. With that, anything else?
I would like to thank you for organizing it. It's very, very much needed and important topic. Thank you.
Oh, my pleasure. Yeah, this one is actually my favorite. Previously, I worked on some AI projects before joining the Azure cloud, so I have some interest on this area as well. Yeah. Thank you
for organizing. This is a good one. So
wait, thank you. Can you share the presentation also?
Yeah, sure. I can share that.
Okay, thank you.
I believe, Yanso, you will create the working group and all the minutes and slides and everything will be in that working group, correct?
Yeah, I will share the meeting notes. You know, we already created the SONiC AI Workgroup. I will work with Lucy to book the meetings, the future meetings with Zoom. And for with the slides, I'm thinking maybe where you can just send out your slides to the work group.
Okay, so there should be a space where we put recordings and slides, right? Let's make sure everyone knows where it is.
All the recordings supposedly will be uploaded or should be uploaded to the YouTube channel. But for this one, let me figure out. I think this one maybe we need some manual steps to export the video and then
talk to Eddie. Eddie, how do we do this in routing so everything is available? You got your
that's the Zoom meeting. The Zoom recording is handled by Linux Foundation. This one is Teams. Use Microsoft infra. I will figure out. That's fine. Yeah, that's a big deal. Okay.
Cool. Thank
you.
Thank you. Thanks everyone.
Thank you.
Thank you.